Hi, this is Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss the topic Direct Memory Access. So, Direct Memory Access is the method. So, using this, we can transfer the large amount of data from peripheral devices or means I/O devices to the memory without involvement of the CPU. So that is called DMA. Okay. So this DMA operation, it is performed by a controller. So that is called DMA controller. So this is a DMA, direct memory access. So DMA controller is a hardware device. It is available in hardware. So it is a hardware device that allows I/O devices to directly access memory, so with less participation of the processor. So that is a direct memory access. So direct memory access is a method that allows input or output device to send or receive the data directly to or from the main memory. So bypassing the CPU to speed up memory operations. So basically, the data transfer through the CPU, it is somewhat slower process. So, in this direct memory access, we are bypassing the CPU. That means we are removing the CPU from the path of the data transfer from the I/O device to the memory. So, this is a fastest way of transferring the data from I/O device to the memory. So, the transfer of data between the fast storage device such as magnetic disks and memory is often limited by the speed of the CPU. So we are removing the CPU from the path and letting the peripheral device manages the memory buses directly would improve the speed of transfer. So this transfer technique is called direct memory access. So during this DMA transfer, the CPU is ideal because the CPU will not involve in the data transfer. So that's why the CPU will be in ideal, and it also has no control of the memory buses. So when the CPU is ideal, so all the CPU will relinquishes all its buses like address bus, data bus, and control bus. So that means the CPU will release all the buses associated with the CPU, so that the DMA controller will take the control of all these buses, so that it can transfer the data, it can start the data transfer from the I/O device to the memory with the less participation of the CPU. So the DMA controller takes over the buses to manage the transfer directly between I/O device and the memory. So here you can see the diagram. So DMA, so how all the devices are connected. So these are the I/O devices, and this is a DMA, and this is a RAM, main memory. So here we are transferring the data from the I/O device to the memory through the DMA controller. So in this data transfer, so the CPU is not involved. So that's why we can transfer large amount of data from the I/O device to the main memory. So the CPU may be placed in idle state in variety of ways. So we can place the CPU in idle state by various ways. So in that one common method extensively used in microprocessor is disable the buses. So disabling the buses through the special control signals. So by disabling the buses, then the CPU will be in ideal. So because without the buses, it cannot do anything operation. So that's why it is a commonly used method by disabling the buses. So you can see the different control signals associated with the CPU. So this is a CPU. So it is having a input signal bus request, and one output signal bus grant, and a bidirectional data bus, and unidirectional address bus, and read operation, write operation. So these are the different control signals associated with the CPU. So the bus request input. So the bus request input is used by the DMA controller, okay, to request the CPU to seize the control of the buses. So we are connecting the DMA controller. So DMA controller we are connecting with the CPU. So the DMA controller will send a signal that is called bus request to the CPU in order to seize the buses of the CPU. So whenever the CPU it receives a bus request signal from the DMA controller, then the CPU will releases all the buses. That means it seizes all the buses, and it will give the permission, or it will grant the buses to the DMA controller by sending an command signal, bus grant signal, to the DMA, so that the DMA controller will take the control of all the buses. Then it can initiate the data transfer from the IO device to the memory. Okay, so these are the bus grant. So bus grant is an output signal from the CPU to the DMA controller to inform the external DMA that the buses are in high impedance state. So when the CPU it sends a bus grant signal to the DMA, it indicates that all the buses which are associated with the CPU are kept in high impedance state. And coming to the DMA transfer. So the position of the DMA controller among the other components in a computer system is illustrated in figure. So along with the DMA controller, some other systems are connected. So like we have interfaced some CPU, we have also interfaced the memory, and also we have connected the different IO peripheral devices. So see here. So here, whenever the IO device is ready to transfer the data, the IO device will send a signal, send a request to the DMA controller. That is called DMA request. After receiving the DMA request by the DMA controller, so the DMA controller will send a bus request signal to the CPU. It will send a bus request signal to the CPU. So whenever the CPU it receives a bus grant signal, bus request signal, it will seizes all its buses. That means all the buses which are associated with the CPU will be released. That means will be seized. Okay, so that means will be disconnected. All the buses will be disconnected from the CPU, and the CPU will grant the buses controlling. Okay, with the signal BG. So the CPU will issue a bus grant signal to the DMA controller. So that means the CPU has given the has granted the permission to take the control of all the buses. So now when the DMA controller it receives a bus grant, then the DMA controller will take the control of all the buses. Okay, and after that, the DMA controller will send an acknowledgement to the IO device. So when the peripheral device it receives a DMA acknowledgement signal, then the IO device will initiate the data transfer from the IO device to the memory through the DMA controller and without involvement of the CPU. So that is called the memory operation. DMA that is called the direct memory access. So then the IO device will start the transferring of data from the peripheral device to the memory. So once the data transfer completed, then the DMA controller will send one interrupt signal to the CPU. So this is an interrupt signal. So the DMA controller will send an interrupt signal to the CPU. So that interrupt signal it informs the CPU that the data transfer process has been completed. So now the CPU, whenever the interrupt is received by the CPU, it disables the bus grant signal. So that means now the bus grant signal will be equal to 0. Then all the buses which are connected to the DMA controller will be disconnected, and that buses will be connected to the CPU. Now the CPU can perform its main operation. That means executing some important programs. And again, whenever in some other time, whenever the IO device wants to transfer the data again, then the IO device will send a DMA request. So this process will be repeated for another bytes of data transfer. So this is a way of how the data will be transferred from the IO device to the memory with less participation of the CPU. And coming to the block diagram of the DMA controller. So this DMA, it is having different registers and buffers. So see here. So address bus buffers, data bus buffer. So in general, the buffers are used to store some data. And 3 registers are associated with the DMA controller. One is the address register, word count register, and control register. And this is a control logic. So using this control logic, we can control the DMA controller. So that are DS, RS. So DS means DMA select, RS register select. So using these two, DS and RS, then we can select that particular DMA controller. Then we can perform 2 types of operations, whether read operation and write operation. So read, write. Then bus grant, bus request to bus grant. Already we have seen in the previous slide. And interrupt. And this is a IO device. So we have one input and one output signal, that are DMA request and DMA acknowledgement. So these are the different blocks associated with the DMA. So coming to the DMA controller registers. So mainly here 3 registers are associated with the DMA controller. So first one is the address register. So already we know the register is a group of flip-flops. So using that we can store some information. So address register, it contains the address to specify the desired memory location in memory or starting address of the memory. So using this address register, in this address register, we can store or we can specify the desired memory location address or the starting address of the memory. So that means from the memory to the peripheral, we are transferring the data. So that's why the starting address of the memory, or from which address onwards we have to transfer the data, that we can store in the address register. And coming to the word count register. So it contains the number of words to be transferred. Suppose if we are transferring some 100 bytes of data from the memory to the IO device. So in this word count register, it will be loaded with that 100. And whenever for every 1 byte of transfer from the memory to the IO device, then the count will be decremented by 1 until it becomes 0. Whenever the word count register becomes 0, then the DMA operation will be stopped. And the third one is the control register. So it specifies the transfer mode. Okay, so because we are performing 2 types of operations with this. So one is the read operation and another one is the write operation. So this read or write we can specify using this control register. And the CPU, it initializes the DMA by sending the given information through the data bus. So the starting address of the memory block where the data is available or where the data is to be stored. It also sends word count, which is the number of words in the memory block to be read or write. And the control to define the mode of transfer such as read or write. A control to begin the DMA transfer. So the CPU communicates with the DMA through the address and the data buses as with any interface unit. So the CPU, it is communicating with the DMA through this address and data buses. So DMA has its own address which activates DS and RS lines. Okay, so using this DMA select line and register select line, then we can select that particular DMA chip or DMA processor, DMA controller. So the CPU, it initializes the DMA through the data bus. Once the DMA receives the stop control command, then it starts the transfer between the peripheral device and the memory. So already we know the application of the DMA controller. So using this, we can transfer the data from the IO device to the memory or from the memory to the IO device. When the peripheral device sends a DMA request, the DMA controller activates bus request line to the CPU to inform the CPU to relinquish the buses. So relinquish means the CPU will seize the buses, because the CPU, when the CPU given a bus grant signal to the DMA controller, that CPU, it doesn't have any control over the buses. So the CPU, it responds with bus grant line informing the DMA that the buses are disabled. The DMA then puts the current value of the address register into the address bus, initiates the read or write signal, and sends DMA acknowledgement to the peripheral device. Okay, so already we have seen how the data can be transferred. So now we are discussing about the bus grant signal. So the direction of transfer depends on the status of the bus grant line. So BG line. So BG line means bus grant. So when BG is equal to 0. Okay. So when BG is equal to 0. So that means when BG is equal to 0, see, the read and write lines are acts as input lines. The read and write are acts as a input lines. That means the CPU is communicating with the internal registers of the DMA. Okay. So when BG is equal to 0 means now the CPU is having the control of the buses. So this read and write lines will acts as a input lines, so that the CPU can communicate with the DMA internal registers. Okay, so that is a case when BG is equal to 0. And coming to the second case, that is when the bus grant line is equal to 1. So that means when the BG is equal to 1, it indicates that the CPU has disabled all its buses and given a permission to the DMA controller to take the control over all the buses. Okay, so when the bus grant line is equal to 1, the read and write lines will be acts as a output lines from the DMA controller to the main memory. That is nothing but random access memory to specify the read or write operation for the data. So this read and write. So this read and write lines will be acts as a output line. That means this read of the DMA controller will be connected to the read of the read signal of this memory. So here. Okay, so this read signal, it will be connected to the read of the memory. Similarly, the write signal of the DMA controller will be connected to the write signal of the memory, so that the memory and the DMA controller can communicate with each other. And when the peripheral device receives the DMA acknowledgement, it puts the word in the data bus or receives a word from the data bus. So whenever the peripheral device it receives a DMA acknowledgement, so this DMA acknowledgement, it indicates that the IO device can start transferring, so that the IO device data, it will be kept in the data bus in order to either to transmit the data or to receive the data. The DMA controls the read or write operations and supplies the address for the memory. So the peripheral unit can then communicate with memory through the data buses for direct transfer between two units, while the CPU is momentarily disabled. For each word that is transferred, the DMA increments its address register. So for each word transfer from the IO device to the memory, or from the memory device to the IO device, then the DMA it increments its address register by 1, and also it decrements the word count register by 1, because for every suppose if the word count register WCR, so let us assume some 50 bytes of data we are transferring. Okay, so suppose if the one word is transfer is completed, then it will become 49. If one more word is transferred, then it will become 48. So like that, until it becomes, this process will be continued until the word count register becomes 0. So whenever the word count register it becomes 0, then the data transfer process will be stopped. Okay. So if the word count doesn't reach 0, the DMA checks the request line coming from the peripheral. Okay. So for a high-speed device, so the line will be active as soon as the previous transfer is completed. A second transfer is then initiated, and the process continues until the entire block is transferred. Suppose if the peripheral device is slower, the DMA request line may come somewhat later. In this case, the DMA disables the bus request line so that the CPU can continue to execute its program. Whenever the peripheral requests a transfer, the DMA requests the buses again. And if the word count register reaches 0, so already we have discussed about this. And when the CPU responds to the interrupt, it reads the contents of the word count register. The value of this register indicates that all the words were transferred successfully. So whenever the word count register it becomes 0, so it indicates that all the data will be transferred from the peripheral device to the memory, or from the memory to the peripheral device, so that the DMA controller will send an interrupt signal to the CPU. Then the CPU will resume its main program, executing the main program. And coming to the DMA data transfer modes, so we can transfer the data from the peripheral device to the memory in two modes. The first mode is a DMA burst transfer, and the second one is a cycle stealing. So what is burst transfer? So in burst transfer, all the data we are transferring from the IO device to the memory, or memory to the IO device at a time. So that means suppose if you are transferring some 50 words from the IO device to the memory. So all these 50 words will be transferred at a time from the peripheral device to the memory without involvement of the CPU. So that is called burst transfer. That means in a single cycle, all the data will be transferred from peripheral device to the memory. So that is called DMA burst transfer. And coming to the cycle stealing. So in cycle stealing, the peripheral device will send word by word. That means first it will send one word from the IO device to the IO device to the memory. So this you can understand with a diagram. So this is a IO device. Let us assume this is transferring some 50 words. So first this IO device will transfer one word from the IO device to the memory through the DMA controller. After that, the DMA controller will send a interrupt signal to the CPU, so that the CPU will disable all its buses and take the control. And now the CPU will execute its main program, and after that, after executing the main program, again the DMA controller will take the control of all the buses. Now the IO device will transfer another word, second word. Okay, next third word, fourth word. So like that, for in between every word transfer, the CPU will take the buses, it will take the control and it will release the control. So like that, this process will be continued until all these 50 words of data will be transferred from IO device to the memory. So here in the cycle stealing, we are sending the data word by word from the IO device to the memory. So that's why it is called cycle stealing, because the name it indicates that the DMA controller will steals the buses of the CPU. So that's why it is called cycle stealing. So these are the two transfer modes of the DMA. So in this lecture, we have discussed about what is direct memory access and its a block diagram and its various methods of transferring the data from the IO device to the memory. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.